Hello, everybody. I'm just reading the comment that I think Ollie's put in the chat here. Hopefully, everyone has had a chance to kind of read through that. So, this is referring to an email that I sent out this afternoon, which is supposed to provide you with the information to upgrade your version of SolidWorks to the more fully featured version. And the reason I did that was that in the coming weeks, we're going to be using some of the simulation features within SolidWorks. So the plan was to begin that next week. Now it's looking like the guide that I've sent out, with it being a couple of years out of date, it doesn't look like it's still working. I think what I'm going to do is there's another lecturer in the department who tends to manage the full version of SolidWorks, so that would be the more fully featured version, and he will know kind of all the details. So Rowan's saying that it's worked for him, so maybe you two could kind of talk to each other, and maybe if it's worked for some people and not for others, you could probably get it working. So he's saying he's on 2018. So yeah, rather than cover this in the session, so Ollie, uh, what version are you actually using? Because it may not be a problem. So yeah, you're using 2020, so that should be fine. Just let me read your message again. SolidWorks to an older version. I sent you an email showing you the warning. Right, okay. So it's trying to sort of almost downgrade you to a previous version of SolidWorks. I'll tell you what, I haven't had a chance to run through the installation on my second machine yet. So my plan was, I've got a sort of machine that I don't use as much here. So my plan was to try and do a fresh installation of the version that I'm hoping that you lot can install, and then I'll know all the specific answers to all these questions. So everybody, unless you want to have a play around with that and see if you can get it working, just give me a day or so to get it working on my second machine, and then if I do get that working, I'll upload a video of me actually doing the install as well. So that should help people. So yeah, for the time being, if people want to hold off from that, and I'll get you the answers for that, and I'll get you them in plenty of time for next week's session. But essentially, the overview of what the PDF guides you through. This is the PDF that I've emailed out to the whole group. It sort of guides you back through going into the. It looks like the installation screen that you see when you first install SolidWorks, but you don't have to uninstall the current version. You just go in and change the serial number. And the new serial number essentially gives you access to a lot more of the simulation side of SolidWorks. So yeah, leave that one with me. I sort of got part way through before today's session, just setting it up on my second machine. So I'll run through the full installation myself, and then if we need an updated serial number from that other member of staff, I'll contact him and just ask him if we've got an updated serial number to get that working. But I had assumed that the previous serial number would give us access, but it looks like maybe not. So yeah, don't worry about that. I'll be back in contact with everyone, and I'll probably, as I say, do a video just showing me installing it, with obviously the sort of waiting that you have to do cut out of the video. So yeah, no one needs to worry about that. So I'll do a bit more investigation. So back to what we were going to do today. I think as we left it last week, we were sort of laying out that drawing of the offset link part. So what I had wanted to do, just to round that task off, was just give you a little bit of information on how to edit the sheet formats. So as I recall it, we kind of laid out all the views, we put all the dimensions on, we had a drawing that looked largely like this PDF that we were working from. So we'd done all the part modeling previously, set up all the drawing, and the only thing that we were lacking was a title block, which is part of the sheet format in SolidWorks. Uh, so we just had the default ANSI title block at that point. And as I say, what I wanted to just round that session off, so that session was covering how to set up drawings and how to kind of create a drawing, just with that extra skill of being able to go in, edit the title block, and then I think we'll sort of leave drawings certainly for a little while. And what I wanted to do this session was do a little bit of work on some slightly more advanced feature types. So we've been using some of the more simple ones like extrudes and revolves. I wanted to have a look at sweeps and lofts, get a little bit into the layout of assemblies as well. So I have a little bit of a practice sort of putting assemblies together of parts. So that was the intention for this session. But let's, as quick as possible, just round off this drawing activity that we were doing last time. So yeah, that's essentially what we're aiming for. That PDF hasn't changed from last week, so it's that offset link PDF. You should have your copy of this drawing, so that you should be able to load that in. So I'll see if I can find mine. I might have to navigate into see if we can find it. SolidWorks drawing, bracket exercise. The easiest way for me is to open something else up that happens to be in the same folder, and then I can browse into that folder. Here we go, offset link. So hopefully you've saved yours somewhere where you can find it relatively quickly. So this was one that I did with one of my other SolidWorks groups because we were using this example as well. So you can see this one's already been edited, but what I'm about to do is put this back to the ANSI format that you will be looking at on yours. So it was ANSI A3, landscape, apply, maybe do a refresh. That's interesting. Try that again. Not updating. Let's try a different one. Hopefully you've already got this up on your screen, but mine doesn't seem to be behaving itself. That is strange. Okay, well there's more than one way to do this. So I'm going to use the tire lever as an example on my screen, I think, because I have that one saved with the original format from the ANSI sheet. So essentially, you should be looking at something like this. This is the standard title block that comes in when you tell the system that you want to use that standard sheet format. And in our case, that was an ANSI format. It was an A3 sheet size. And one of the reasons, certainly in this tutorial, that I decided to get rid of a lot of this information was that a lot of this is specific to working in a sort of large organization. It's traceability. So a lot of this could be linked in with ISO 9000 in terms of being able to trace the work that various people have done within the drawings department. And certainly for these examples, it's a little bit overkill. We don't need all that information. But it's a nice sort of way into just teaching you a little bit of how to edit these sheet formats. and how to kind of make them appear as you need them. So ignore the drawing that we're looking at here. You'll be looking at the offset link drawing. You need to have none of the views selected. So the first thing that you want to do is just press the escape key to make sure that you've got none of these views pre-selected. And then the easiest way to get into the mode where you can edit the sheet format is just zoom in on a portion of the sheet format. So in this case, I'm zooming in on the title block, right click over the top of it and go to edit sheet format, like that. And two things will happen. One is that all your views and annotations and everything will temporarily disappear. Don't worry, they haven't been deleted, they've just been suppressed. And if you look over to the left-hand side where we can see kind of the makeup of our drawing, you can see that because we're editing the sheet format up at this level here, everything that was created after the sheet format, so that includes all our views, have been temporarily suspended. So it's a little bit like when we're in the part modeling mode and we can grab the blue model bar at the top and we can rewind in time back to a previous sort of state within our part. The system's essentially done the same thing. It's rewound before we created any of our views and we're inside the sheet format, ready to edit the sheet format itself. But when we've done here, we'll exit in the same way that we exit Sketch normally. So you can see there's a similar icon up at the top right there to the Sketch one, and all those views will be unsuppressed, so they'll all appear again essentially. But what do we want to do to the actual sheet format? Well, in this example, we're going to trim off a lot of the table cells to the left here. So we want to kind of get rid largely of this side of the table in this instance. But the thing that we've got to be aware of is that the way that these tables are kind of made up in SolidWorks is just as a sketch of straight lines. So there's nothing in terms of table management like you would get, say, if you insert a table in Word, you can kind of easily drag cells around and the Word kind of takes care of managing the rows and columns. SolidWorks kind of doesn't work like that in terms of its sheet formats. These are just completely sort of underdefined sketches, and I'm kind of illustrating that just by ruining this table. So you can see there's nothing particularly sort of that we haven't encountered before here. It's just a sketch with a number of lines running through it, which is kind of a good thing, but it's quite dangerous as well. You can quite easily ruin the table, is the kind of point that I'm trying to get to here. And I have ruined it there. So you've got to be careful as you're editing these things. Now, the other option here is you could dimension all this up. So you could make this fully defined. But kind of the dumb thing in SolidWorks is certainly with your title blocks, it's okay to leave them underdefined. And you can see that the title blocks and the sheet formats that actually come packaged with SolidWorks are completely underdefined. I say completely. There's some relations in here. So let's click on one of these lines. Let's click on an endpoint of one of these lines, if we can. Nah, it's not showing up there. But essentially, the endpoint of these two lines is shared. So there must be a coincident relation there. It's just that the display of the relations when you're editing the title block has been switched off. Let's see if we can switch them back on. There you go. So in the same place that we show and hide the planes, there's an option for showing and hiding relations in sketches as well. So I'm just clicking on that. And you can see there's a minimal amount of relations in here, just holding certain ends of lines in place. But essentially you can regard this as a completely underdefined sketch. So be careful as you're editing it, is kind of the bottom line. So with that in mind, obviously I've just pressed undo there just to get back to where I came in. I've said that what I want to do is get rid of this part of the table, and if I try and do a box select on just that part of the table, There's certain lines that run the full horizontal length. You can see that's an example of one. That's an example of one. That one doesn't quite go the full distance, but it certainly comes through this wall that I'm intending to chop back to. So what I need is a sketch tool that will separate the two halves of the table. And we've used that sketch tool before. It's the Trim Entities tool, which was it's the tool that you just essentially draw a freehand line with the mouse pointer, and anything that that line touches gets trimmed back to its nearest neighboring line. So we're going to use that tool in the Sketch tab. And within that tool, there's various different setups of how you can have the tool behave. The power trim is the one that we've encountered, and that's the one that we're going to keep using for this example. And then just to illustrate, I'm just going to click and hold and just draw that freehand line. So when I'm ready, I can draw through the horizontal lines that I want to separate from their nearest neighbour. So I go all the way down through there. Make sure you don't hit the sheet border. I haven't done the experiment as to whether it'll chop the sheet border, but probably best not to risk it. And then we don't need the trim tool anymore, so we can just click on the green tick up by the trim tool. That shuts the trim tool down. We're still actually in editing mode. And again, it seems obvious, but essentially we're just in sketching mode. And we kind of know how to operate when we're creating sketches. It's nothing new. We've done all this before. So we're in this sketch tab at the top there. We can create any of the shapes that we normally create in sketches. As I say, you can add dimensions in, and kind of the system behavior is when we are finished editing this title block, the dimensions will get auto hidden when we go back to editing the sheet. So they won't kind of hang around. They'll disappear, the dimensions. So you don't have to worry about that. But kind of the way that you work is you don't really dimension things when you're editing the title block. The only other bit of this kind of left-hand portion of the table that I want to retain in this example is this little note here. So the note just outlining what units we're working in. I think on this occasion I'm going to retain that. And on the example that we're kind of working towards, it retains a little portion of that note. So you can recycle bits of this. So what I'm going to do is just click and drag that over there for the time being. And then I'm going to do a box select on all these items that I am now going to delete. So if I click just above it to the left and then drag down, and in case you didn't know, on most, certainly most programs that I've encountered on Windows, if you do a box select from the top left down to the bottom right, the behavior of that is that in order for things to be selected by it, they have to be entirely inside the box. So the reason I'm highlighting this, you can see that number 3 and number 4 at the bottom there aren't entirely inside the box. Therefore, when I let go, they're not selected. And later on, we'll do a bottom right to top left, and that's kind of the opposite behavior, as in anything that's even partially inside the box gets selected, as well as everything that's fully inside. So yeah, top left to bottom right, or bottom right to bottom right to top left. They both have sort of the different behavior, certainly in SolidWorks, and I think other things like Word and Publisher and things like that sort of behave the same. So when we've got all the things selected that we want to delete, just hit the delete key. Now I think I'll edit the text in this note, so we can just double click on the text to actually drop into text editor mode there, and we can delete the bits of that we don't want, or possibly add some more text in there if we did want it. So we'll go to there. We don't need to edit the note anymore, so I need to click on the green tick over here to get out of that text editor mode. Then I can drag the note around. I think I'll drop that one in there. And then again, if we have a look at what we're working towards and just zoom in a little bit on this. So we've got the text, everything else is pretty much as we've got it. We're going to have to enter a name in here. Now, I've slightly corrupted this sort of naming convention that you're expected to use with drawings. And the reason I say that is the name that we saved this part out as was offset link. And generally, the done thing, and these drawing sheets are set up with this in mind, is that the drawing number, so the bit of text that's in here, the system auto-populates it, or auto-populates this box with the part name. So whatever you save the part as, that's what gets inserted automatically into that box. And the thought is that you would most likely save the part out with some sort of coded name. So something like STV1701X or something like that. Something that would be difficult for a human to read and understand unless they were kind of well versed in the naming systems of your particular company. So that's what is kind of intended to go in that box. Some sort of non-human readable name, just a reference that, say, your stock system in your company would then have a reference to the part number. Whereas in this box, the title, what's intended to be in there is something that's a bit more intelligible for a human to read. So, as I say, in this particular example, just to keep the name of this part simple, I've kind of corrupted that system slightly. And this kind of more descriptive name is almost identical to this name. But that's kind of the intention. On these sheets, the ANSI sheets, the BSI sheets, that's kind of the assumption that the person who created the sheet was making. And to be honest, that is kind of how you'd use this. In any sort of organization that's beyond, I don't know, 10 employees or something like that, you tend to use part code numbers to actually save the parts out under. But anyway, so we're going to have to enter a bit of text in this one. We're going to have to create the third angle projection symbol. Unfortunately, we're going to have to do that manually, but we only have to do that once, and then you can save that out and keep importing it into all your new sheets if you want to. So let's tackle a few of those. Let's create the third angle symbol first. So again, we're just in sketching mode. So we know how to draw circles in sketching mode. We know how to use the line tool to create straight lines. If you remember, I'm sure we covered you can turn your sketch geometry between solid lines and what's known as construction geometry, which is essentially a dashed line. So with those tools, we should be able to create this third angle projection symbol. And I think probably the most logical place to start is the circle. So we'll get the center point circle tool. I'm just going to click somewhere there, drag out for the larger of the two circles. I don't want to go too near the boundary because I've got a center mark sort of X that needs to go beyond the edge of this circle. So I want to stay a distance away from the actual cell boundary. So I'll click about there. Second circle, I want it centered on the center point of the first. So you want to kind of hover over the first one until you see that concentric relation popping up. And about there. Then I'm going to switch to the line tool. And initially, I'm not going to start drawing this conical shape from the side. I'm just going to put some projection lines between the kind of north and south points on these circles and over here to the right. So I'm going to create some lines that I'm then going to delete later on, but they're going to give me a reference of where I need to start drawing this cone on the side view. So I'm going to click on that point there. You can see when I hover over that larger circle, sort of the 4 points of the compass become visible. We've got north and south and east and west. I'm going to let it lock itself onto north, and then I'm going to drop it about there. So I've got a horizontal line coming out, a projection line. And then because I don't want to keep pressing escape to come out of the line tool just to go back into the line tool, I'm going to sketch a diagonal back to the north on the inner circle there, and then click again, and then back to about there horizontally, and then the south point of the inner circle there. And then you can see when I get vertically below that other point there, I get a little dashed line. When I get that, I want to click, because I know that I'm perfectly vertically below that point above then. So click there, and then south on the larger circle, and then back to there. And then I can start actually sketching in this side view of the cone shape. So I'm going to put a line up to there, and then I'll put the vertical kind of front edge of the cone in as well, and then top edge there, and then the rightmost vertical there. So I've got my cone shape. I've got a load of extra lines that I don't need, but I'm going to delete them now. So I don't want to sketch any more lines at this point, so I'm going to hit the escape key to get out of the line tool. And then we're going to use the selection rectangle again, but we're going to go bottom right to top left this time. So I'm going to start there and go up to there. And you can see there's nothing that's entirely inside that selection rectangle now. But it doesn't matter, because I'm going from bottom right to top left. Anything that is even partially within it gets selected. So there. I've got all those extra construction lines that I put in all selected. Press the delete key to get rid of them. So we're nearly there. All we need to do, we need to put a center mark on the kind of front view of the cone there. And then we need to put a center line through the side view there as well. So again, there's sort of logical order that you want to create these. You want to do the center mark first. And the reason I say that is as we create the center mark, we'll create a point at the center of these two circles. And what the system will then allow us to do is, as we're drawing the center line here, it will align the vertical position of that so that it's horizontal, with that point there. So it will ensure that they're both aligned with each other again. So back to the line tool. We don't want a standard line, because standard lines are just point to point. And in this case, we want to select the midpoint of the line first. We don't want to go from one end of the line to the other end as we're creating it. We want to go from the center, the midpoint, out to one end. So there's an option for that, just there, midpoint line. So if you click on that, and then if you hover over that inner circle till the center point of it appears, and then click when you see that concentric yellow icon appear, because that's going to put a relation between the center point of our line, or the midpoint of our line, and the center of the circle. So you can see what's happening there. As I drag this line out to the side, the opposite side of the line is growing and shrinking as well. So I'm going to put a horizontal leg in there, and then press escape, because I want a new line now. So back into the line tool, another midpoint line, and then just do the same again, but vertically like that, and then press escape again. And then we're going to put the center line in. So that was the center point. Now we're going to put the center line in, line tool again. This time it's just a point to point line. But as you can see, now that I've put the center mark in, I get that dashed kind of projection line away from it, which means I can ensure that this line is perfectly vertically aligned with that center mark that I've just put in. So click there, and about there. Yeah, that looks okay. And then one last thing to do on these, just make the center mark and the center line appear in that sort of dashed center line font that you get on this third angle symbol. So I'm going to click on one of them, hold down Control, click on the other two, still holding Control, and then it's that option there for construction. So that tells the system these, if we were in a sketch that we were going to create a feature from, these would be regarded as not solid geometry. They would just be there either for our reference as the user or to hold another piece of solid geometry in place. But they work for this purpose as well. So we'll click on OK. And then what I'd probably like to do is kind of bump both of these across to the right slightly, which can create some problems. Let's have a go at box selecting them and moving them and seeing what happens. Yeah. So again, because they're completely underdefined, they kind of don't want to stay together as a group, basically. You can try and select them and drag various points of them. That seemed to work. So it's a little bit difficult to move them around without inadvertently dragging a point out of place, like that being a good example. So it is possible, but kind of a more foolproof way to move them around is the Move Entities tool on the Sketcher toolbar again. So if you click on Move Entities, there's two things that the system's waiting for here. It's waiting for some input there as to what exactly you want to move. So we could just do our box select again. Try not to grab the note. So let's try that again. I might go bottom right to top left this time, like that. So there's all the entities selected. They've all been entered into that blue entry box there. And then the second box lower down that you have to click on to activate is essentially a from and to translation, I suppose you'd call it. So you click on a point where you want to move from. I'm going to pick the center of this circle. And then wherever I click a second time, that's where that point will get translated or moved to. So you can see it's kind of following my pointer at the moment. Let's say I wanted to move them out here. I'd just click and then click on the green tick to OK that. And you can see the effect that that has. So either way, but the move option, if you've got a set of edges or a set of lines that are completely underdefined, so they're not dimension relative to each other, moving them using the Move Entities tool is probably the safest way to do that. So I'm fairly happy with where they are now. So I need a little bit of text there that just says third angle, just to clarify. Because I don't want to have to go in and define what font I want, what size I want at the font, all of that setup information. What I'm going to do is I'm going to just take a copy of that word title there and then just edit the text, which is probably the easiest way of doing it. So you can do a copy and paste with any of these elements, but the easiest way is just to select the thing that you want to copy, hold down Control, and then left click and drag into a new location. And it just creates copies of whatever you've clicked on. You can see I've got 4 of them now. So if you want to practice that, once you've done one copy, select that one, hold down Control, left click and hold the mouse button, and then just drag to a new location like that. And that kind of works with anything in these title blocks. So I'll just position that text. You can see it kind of tries to align itself with some of the existing features. I get these little kind of lines. That can be useful or quite annoying, depending on what you're trying to achieve. Yep, that looks okay. And then again, to edit it or to go into text editor mode, double click on the note and you can overtype with whatever you need. So I think we said third angle. Now I've specifically left mine not all in uppercase there, and that's because there is an uppercase option in the note dialog on the left here. And just generally, it's better to do it that way because then you've got the option. If you want to revert back to not uppercase, you just untick that option there. Whereas if you type everything with caps lock on, that's non-reversible. You can't go back to lowercase again. You have to retype everything. So that's the third angle. I don't need that word title, so I'll just delete that. And then I think we've only got a couple of things to do. We've got the description text, the title as it's called here, just to enter, which you probably spotted it then, but there's already a text box there. And I know that by the fact that as I go near it, as I get inside that invisible text box, my icon of my pointer changes to kind of a letter A, which basically means I'm pointing at a piece of text. You can see that happening when I point at all these pieces of text. So there's an empty text box there, which means I can double click on it and enter whatever I need to. So again, this tends to be the more sort of wordy description of what the part actually is, whereas the thing below that also says tire lever in this case would normally be a code of some kind that relates to what the part is called. So yeah, you'll be writing something different. You'll be writing linkage, whatever the word was. I'll just leave mine as tire lever. And again, a common mistake when you're editing these for the first time, you press enter thinking you'll okay the text entry that you've just typed. It doesn't work like that. Pressing enter just gives you another line to type on in the text box. So don't make that mistake. In order to okay the edit that you've just made, you have to click on the green tick up by the word note on the left-hand side there. And that will exit out of text editor mode. So I think there's only one last thing to do, and that's just put a cell boundary between these two table cells, essentially. Which, again, if we have a look at the reference, it's that line there, which isn't terribly difficult. It's just the line tool again. We're just in a sketch, so I'll let it lock itself onto that horizontal, let it lock itself onto that one, and then hit the escape key. And that's essentially it. We've done a fairly simple edit to a sheet format there. Now, in order to get back into standard drawing mode where we can edit our views or add more annotation, you have to exit this special sketch that we're in, because that's kind of all the sheet formats are. They're just a sketch that happens to be labeled as sheet format, not sketch. But you have to exit them in the same way that you would exit a sketch. So you can see at the top right, there's a kind of icon with a blue arrow. Looks a little bit like the exit sketch icon. You've got to click on that. And then it locks the sheet format. We can't edit it anymore. You can see if I go in and try double clicking on things, it won't let me. So we've come out of sheet editing mode or format editing mode, and we're back into standard drawing layout mode. So we can move views, we can edit annotations, whatever we need to do. If we want to only have to do that operation once, so we've decided on a sheet format for our drawings, we've decided that we're going to have to edit one of the standard sheet formats that come with SolidWorks to turn it into our preferred sheet format. You only want to have to do that task once. You don't want to have to do it for every single drawing that you create. So the way that you would save out a copy of the sheet format itself is pretty simple. It's just when you've done your edits, doesn't matter if you've got drawing views on the sheet, they'll not get saved because they're not part of the sheet format. You just go to the file menu and save sheet format is an option there. And then the only thing that you really have to remember is where you put it on your system, because by default it's going to try and browse into the SolidWorks installation folder. So when we're all on site, which I know we're not at the moment, but when we are, this is where I have to tell people that the systems won't let them save into the program installation folders. But obviously, if you're using your own equipment, you've probably got full administrative access in there. So you can save whatever you need to save in there. You can see I've put a few custom ones at the bottom of that list myself. But you don't need to save them in there. If you want to just stick them in your documents or somewhere else on your system, you've just got to remember where you put that sheet format. And the next time you come to create a sheet, so I'm just going to simulate that now. So say I was creating a new drawing. Here we go. And then in this selection screen here, I'd just browse to wherever on my computer that I'd saved that, and then just load that in. Or The ones that are in the SolidWorks installation folder are all listed there. So I could load it in with one of those formats on, so you can see there's a custom one. So yeah, that kind of rounds out what we were going to do in terms of setting up drawings and editing the sheet formats. Is everyone okay with that? Did everyone sort of follow that? Do we need to go over it? I think, again, is the question that I'm asking. Anyone in the chat? Yeah, all good. Okay, I'll assume we're okay on that one. But obviously this session will be recorded, or it is being recorded at the moment. And then more than that, there's two sort of standard SolidWorks drawing videos that I think I posted them last year or maybe the year before. And they kind of cover all of this. So these two here in this list, SolidWorks Drawings 1, SolidWorks Drawings 2, kind of covers everything that we've just done there. So if you need to dip back into them, that would probably be the place that I'd go. And it means that you can kind of fast forward or rewind through them and just find the bit where I'm obviously editing the sheet format, and you can get the info there anyway. Right, back to the next thing that we were going to tackle, which is down the page a little bit. So it's this one with the kind of 3 screenshots that I've put on there. So if you want to follow along in the PDF, which is what we're going to work through, you can open that up on your screen. And this is it's kind of an expanded version of the PDF that we started on in week 1. You can see a lot of these examples. We've worked through these already. So if you want to navigate down to the bit where we're going to be working today, it's this section here, Sweep and Loft. So you can just click on that and it will jump down to that section. So I think the first thing that we're going to tackle is the sweep, and we're going to have a go at that example there, which is a paperclip shape. That's kind of all we need in terms of guidance, because that has all the sizes on that we're going to need to create. So just to sort of describe what a sweep is, or what a swept feature is, it essentially takes a shape, it refers to it as a profile shape. So in this example, there's a tiny little kind of blue sketch, which is just a circle. You can see it there. It has a diameter, so it has a 1 mil diameter in this example. So the system takes that profile shape and it sends it on a journey along a path. So the pink sketch there that I've highlighted, that's a second sketch. So this was a first sketch. This happened to be on the front plane. This pink line was a second sketch that happened to be on the top plane in this example. What the system does in a sweep or a swept feature is it takes that profile shape and it sends it along the path shape. And any kind of volume that inscribes as it travels along becomes a solid piece of material. So in a way, it's similar to the extrude, but whereas the extrude, you can only send the shape off in a certain direction, a single direction that just happens to be a line. In this, we can kind of direct it round corners or in any other sort of shape that we want. So yeah, we'll have a go at that one. Then I think we'll just practice what we've done, and we'll have a go at this kind of split pin shape as well. And then we'll talk about some of the kind of more advanced options within sweep. So this is a sweep as well, but this has some extra options. And what I've done is I've shared the starting point of this part. So that's why it doesn't have any dimensions on in this screenshot, because it's actually shared there. So you can see sweep and guides, solid part. So we'll tackle these first two that are in the PDF first, and then we'll load that one up and we'll have a little play around with guide curves on that one. So back to what we were doing. So I'll just get that on my other screen so we can keep referring back to it. And we just need to create a new part. So I'm going to shut these drawings down. If you want to take a save of them, if you want to, what you can do is you can probably copy and paste the third angle symbol from one sheet format to another. So if you want to take a save of what you've done in this session, it might be useful just to stop you from having to draw the third angle shape again. But I don't need that, so I'll get rid of it. Shut that one down. Shut that one down. Shut that one down. And we definitely don't need that. And I have that open in the background. Right, so I'm going to create a new file. We know how to do that by now. So double click on part, should drop into the part interface. I think in this case, which one shall I create first? The circular sketch or the path? I think we'll create the path first. Yeah, that seems logical. So in this case, the path is sketched on the top plane. And in this instance, we're not initiating a feature straight off the bat. So in the past, we'd maybe clicked on extrude and then the system's asked us to create a sketch. The sweep feature, or the swept boss base, to give it its correct name, you kind of create the sketches first, or at least one of the sketches, and then you initiate the feature. So this is a little bit different in terms of the workflow of how you actually set the feature up. So we're going to go into the Sketch tab. Click on Sketch tab. Click on the first icon, which is Initiate a New Sketch. And then the system asks you, what plane do you want to create the sketch on? So we're going to click on that top plane. Then we've got to draw this kind of path shape. And again, if we just have a look here, where's the origin in this particular setup? This is a good question. It should be, I think the origin's there. I could have done this screenshot more clearly. So there's the right plane. So maybe the origin is on the circle here. I think I'm going to draw it as if the origin is at the starting point here. So the other thing that I'm wondering about in terms of this shape is it worth drawing a straight line initially and then a tangent curve on the end of it and then stopping for a moment and getting the size of those two correct? I suspect it probably is, because having drawn shapes like this before, what you can end up doing is you draw the entire shape, but the scale and size of it is entirely wrong. And then when you start adding dimensions to it, I think as we've seen before, the shape gets kind of pulled inside out, and yeah, you end up with nonsense basically. So I think we'll put that first. I think in our case that'll be a vertical line, and we'll put that first arc in, and then we'll pause and we'll put some dimensions on them so that we can be fairly sure that as we're sketching the rest of the shape, we're at approximately the correct sort of scale. So let's do that first. So I'm going to get the line tool. I'm going to go upwards. I get that little readout. So I'm aiming for around about 18 millimeters, which is tiny on the zoom level that I have on my screen. Then I'm probably going to use the curve tool or the arc tool, but instead of the 3-point arc, which is what we've used before, we're going to use the tangent arc. So if you click on tangent arc and then click on the end of that line, come out to the right slightly and then click again, you can hopefully see what the tangent arc does. It kind of does what it is named as. It puts a tangency relation between its first point and any line that you've attached it to. So I don't need that tool anymore. So you can see it's trying to give me another tangent arc here. So I'm going to hit the escape key to get out of that. Then I'm just going to point out that tangency. So because I attached it to the end of that first line, it was happy to apply that tangent relation between the two. So that's why I used that tool rather than the 3-point arc, where we had to manually put that in. So I'll get my smart dimension the length of the line, which is 18. dimension the radius of the arc, which is 4 in this case. And then probably what I'll do, because I want another vertical line here, I know that the extent of this arc should be 180 degrees. So it should go down to there. So what I'm going to do, select the end of the arc, hold down Control, select the center of the arc, and make them horizontal with each other. So I know that that arc has swung through 180 degrees as it's sort of finished there. And then we'll continue sketching. So let's get the line tool. Let's go. So what's the length of this one? This one's 25. So again, you get that little readout, which is quite useful. Down to around about 25. And then it's a difficult one to get the system to do, but if you move away from the end of that line and then go back towards the endpoint and then come away again, it gives you the arc tool, although it's not giving us the correct arc tool there. So we probably press escape. So that's a little trick that's supposed to speed up your sketching. You can switch on the fly from a line tool to an arc tool. But in our case, it's not that useful because it's not giving us the tangency. It's kind of gone off at right angles to... So I'm going to hit escape. I'm going to manually select the tangent arc again. And then click on the end. And then I want to come just inboard of that vertical plane. Because obviously this is a paperclip shape. So I want to kind of spiral round as I kind of progress. Then I'll press escape because I don't want the arc tool anymore. Back to the line tool. One that goes up there. That's about 21, 22, something like that. So around about there. Hit escape. So it's advantageous if you kind of hover over the escape key as you're doing this, because you keep having to press the escape key. Then I've selected tangent arc there, but it's not giving me the tangency that I wanted, so I temporarily hit the escape key again to about there. Escape key again. You get the idea. And then I think this is the final leg. I think this is where it terminates. Yeah. And then it meets that plane there. And then we can press escape. So that's essentially the shape that we want. All we have to do now is kind of dimension the bits that are shown in the image that we're working from. So Smart Dimension tool, that leg there is 25. This leg in here has got strange measurements. That's 21.75. Some strange reason. I can't remember why I set it up like that. And then we have a 15 in there. That one looks like the 15. Yep. Aha. Now that's interesting. So it's not allowing me to put the 15 in. I suspect I'm misinterpreting the image. Yeah. So we've kind of only got the spacing between these two dimension now. The actual lengths of them have been locked down. So there's a spacing width in there. I think it's 1.5 between legs. So between that leg, say, and that leg, 1.5, like that. And then what we can do here, I'm pretty sure we haven't covered equations yet, but if we click on that leg and go to set the spacing, we want it as 1.5, but rather than just type that in, if we press equals and then click on this 1.5 there, it kind of samples that value. So it puts a little equation in there saying this value should always equal whatever that value is set at. And the way that you activate that is, rather than typing a static value in there, 1.5 in this case, hit the equals key and then click on any other dimension, and it will put that little equation in there linking this one to whatever that one's set at. Now it's a one-way link, so this one gets calculated from that one, not the other way around. So it would be this one that you'd have to change if you wanted to make a change on both. So then we click on OK. It evaluates that. It puts a little equation symbol at the side of it just to indicate that it's not user editable. So if I double click on it to go to edit it, I can't edit the value. All I can do is change the equation that's generating that value. And if I wanted to do that, I could just overtype. I could change it to whatever value I needed. But in this case, that's what we need. We need it to be equal to whatever that one's set at. So I think we're done. In terms of the path sketch, that's the shape that we want. So we're just going to OK the sketch, which we've done before. So that's kind of the shape that we've got. Then what we're going to do, because we sketch that shape to end on a particular plane, that wasn't by accident, that was a sort of intentional thing. And that's because the profile shape, we need to sketch at 90 degrees to it. And rather than have to create a new plane, which we could do, it's easier just to use one of the primary planes. So that's why that line there terminates at that front plane, so that this profile shape, we can use the front plane to sketch on. Yeah, so let's do that. So we're in the sketch menu still. We want to initiate a new sketch. Rather than clicking on the sketch icon up here, what you can do, if you want to work a little bit quicker, is pick the plane first. So I'm going to click on the front plane, and new sketch is one of the icons that pops up there. So that icon there creates a new sketch on that plane. And then because of what we're trying to achieve here, we're trying to create, in this case, a circular shape that is centered around the end of our first sketch. So it's kind of centered around that line. And that's the reason I've kind of rotated my view to more of an isometric sort of viewpoint, because it's kind of easier to see that and that relationship if you're not looking kind of straight on at the line like that. So all I want to do is get the circle tool, lock the center of the circle to the end of that line, drag the circle outwards, get the smart dimension, and set it as 1 mil diameter. And that should be fully defined because it's locked itself automatically to the end of that line, which happens to be the origin as well. But again, it needn't be. If the line hadn't stopped at the origin, if it ended up over here somewhere, we could have locked the circle onto it regardless. So the fact that it's on the origin is just a coincidence in this particular part. In fact, let's illustrate the point. Let's lock it to the other end. So I'm going to delete that coincident constraint, drag this circle over there, hover over the other end, and you can see it's as happy to lock it onto that end of the path sketch as it is to this end. So we're happy now. We've created the two sketches. We're ready to create the sweep feature itself. So I'm going to OK that sketch. And then normally what happens is you're setting these features up, you forget to deselect whichever sketch you've just created. So it's worth just paying attention. And as I now click on the Swept Boss Base tool, it will accept that sketch that I've got pre-selected. So again, people can get themselves into sort of trouble that they didn't expect. You just got to pay attention and see, have I got any sketches pre-selected here? Because as soon as I activate this tool, it's going to look at the sketch that I've pre-selected and try and enter it into one of the two entry boxes. So I'll leave it selected and we'll click on the Swept Boss Base feature. And there it has done what I've just said. So that first box normally would be highlighted in blue, and that would mean the system is waiting for a profile sketch to be selected. But in this case, it used a little bit of intelligence and kind of said, the sketch that you already had clicked on or not clicked off, in our case, I'm happy to put that in that box. And it when it does that, it then automatically jumps down to the lower box, which is the path. And the two icons for these kind of different sketches tell you the story. It looks very much like one of the corners round our paperclip shape. So you can see the path one is highlighted there, and you can see the circular shape, the profile, it has been greyed out. And you can see on the top one, it's the profile shape, the circle that's highlighted in blue, and the path has been greyed out. So the icons kind of tell you which one's which. So now I'm just going to click on the path shape, and you should end up with something that looks like that as the preview. And then if you're happy with that, click on OK, and you've got your sweep. So yeah, the similarities with the extrude feature, which is kind of a more basic feature. But if you think about it, it's an extrude that you can kind of steer around corners. But it kind of behaves sort of similar to that. But in order to define those corners, you need a second sketch, whereas the extrude can be created with just a single sketch. This one needs two. So yeah, that's kind of the basis of the sweep. I think what we'll have a go at is we'll try and create the split pin now. And then, as I say, we'll move on to what's sort of a special case sweep there. Or maybe we'll go to Loft first. Yeah, I think we'll go to Loft, and then we'll double back and we'll just have a little look at that special case after we've done the Loft. So yeah, let's have another go at that, but using this split pin as an example. My Windows managed to minimize itself. See if I can get it back. There it is. If you want to take a save of that, you can. I think I'm going to get rid of mine, or I'll probably just minimize that. So, new part, double click on part. In this case, the setup's going to be similar, although we're going to use a slightly different shape. So let's create the profile shape first on this one. So in this case, the profile is kind of a D shape, so it's kind of a truncated circle, which is this shape here. So that's what I'm going to create first. And again, I've chosen to orient this in a certain way relative to the primary planes. You could choose to orient it a different way. There kind of isn't a right and a wrong, but you've got to pick one of the planes to begin on. So in this case, I'm going to sketch on the front plane. So yeah, I don't want to keep going up to the sketch menu, because any kind of minimizing that you can do in terms of the travel of your mouse, it obviously speeds up your workflow. So just click on the plane, click on the sketch icon. That's what the system kind of puts those there for, to try and speed up your modeling process. And then the quickest way to do this is probably create a circle first, like that, and then have we got a radius? No, let's put the line in next. Then get the line tool, and then draw a vertical line approximately in the right position like that. And then I'm just going to use the trim tool to trim away that extra or that excess piece of circle there. That's probably the quickest way of creating the shape that we need. So trim tool, power trim, straight through there, and then OK the trim. So we don't need the trim tool anymore. And then I think, so what's the offset here? It may have gone wrong already, but we'll persevere. So there's a offset between the center point of the circle and where that vertical trim is in our setup, and that should be 1 mil, like that. And then if we dimension the radius as it should be, so that should be 2.5, like that. And then we need a distance away from that vertical plane, or away from the origin. I believe that is 2.5 in this setup, but we may revisit that. It's not 100% clear. So I'm going to put 2.5 in for that one there. So in this one, we're kind of approaching it in the opposite way. We're creating a profile shape first. We're defining its position as well. So obviously the kind of shape of this has been defined by the radius there and by that figure there. But its position in space is defined by that. So that's relative to the origin or the primary planes. And the fact that it's coincident with that plane there. So yeah, the two things, they're kind of define distinct sort of elements about it. One is the shape, one is its position. This position one, we may come back in and modify that later on. But if we OK that sketch now, and then again rotate off axis, as we create the profile shape now, we're going to have to lock it to some point of this sketch. So just as we did on the other example, the paperclip, but we did it the opposite way around. We locked a circle to the end point of a sketch that we previously created. This time we're going to do it in reverse. So I think we'll create our sketch on the top plane. And again, you can see the default behavior of the system is to scale the base planes relative to the things that you've created. So in our case, we've created this very small partial circle, which means it's scaled this top plane relative to that. But if we really want to see the top plane much bigger, you can just click on the drag handles there. So I don't think that it has actually scaled the plane down to that. It's just the way that it kind of shows it to you, the user. So click on the top plane, click on sketch, and maybe rotate round again. And I'm going to get my line tool and just put what the system refers to as vertical line. You can see the vertical relation appear in there. Click and then press escape, because I want to do a little bit of work on this line first. I want to lock it in position. I'll probably put a length on it as well, and then I'll progress with sketching the rest of this path shape that we want for this split pin. So the first thing I'm going to do is I'm going to lock the end of my new line to intersect with that vertical edge there of my original sketch. So I'm holding down Control. And the relation, as the system calls it, is pierce. So this is where two sketch elements meet, but they're on different planes. So the pierce command, essentially our line that we've just created, the blue line, is piercing the middle of that vertical line. So pierce like that, locks it into position. That's what we want. We've already locked it to vertical because obviously when the system rotated around to view this plane normal to it, it was oriented something like that. So it calls that vertical. And then we just have to define the length. So smart dimension, click on the line, and this one is 90. So we're going to have to zoom out a bit. The zoom all command, I think we covered that on week 1, but again, it's worth revisiting. So I could wind my mouse wheel and zoom out, but if you have to do that a lot, that's quite time consuming. Just click on the scale to fit. I think it's called scale to fit. See if I can get the tooltip. Zoom to fit. So it's that icon there. A lot easier. And then basically what we want to do is we want to create some arcs to get around this 180 degree angle at the top, and then create a mirrored copy of this line. What we could do is create the mirrored copy now, seeing as we're just about to create the arcs, and creating the arcs when you have both of the lines in is probably easier than trying to do half of them and then mirroring this line. So let's take a mirrored copy of this line. I can't remember whether we've used the mirror tool already, but if we haven't, it's there on the sketch toolbar. So click on mirror entities. The first box is what you want to mirror, and the second box is what is the plane or the mirror itself. So what plane or what line do you want to mirror them about? So entities to mirror, in this case, is just that line. Click on the line, mirror them about, so I've clicked on the second box, and in this case it's the right plane there. So you can mirror them about another line that's in the sketch, but again, the way that we've oriented and sort of positioned this part, that right plane happens to be in the exact right position, so we can use it to mirror about. So click on the right plane. If you're happy with what you see, click on the green tick. You can see that my icon or my mouse pointer has got a mouse icon at the side of it with a little green tick on the right hand button. That means you can shortcut to OK in this mirror by clicking the right hand mouse button. Again, the system's just trying to save you time. That looks okay. So we've got 3 arcs that we want to put on the end of this thing. And I think, now let's use the standard 3-point arc. So we're going to go something like that initially, and then something like that, and then something like that. So that's a reasonable starting point. It's by no means the shape that I want it to look like finally, but what we're going to do is put some relations on it to lock it in position. What I'll probably do at that point is go normal to the sketch, like that, so I can kind of see what's happening a little bit easier. And then it's just 3 or is it 4 tangency relations that we want to put on initially. So I'll put a tangent there, I'll put a tangent on there as well, and then from what we did the other week, it kind of sometimes helps to try and drag things into position. Yeah, so you can see as I drag this arc larger and smaller, at that point I can visually just see that it's almost tangent there. So at that point I'd add that tangency relation in. And this is, again, trying to avoid your sketch being kind of pulled inside and out by the addition of these relations. So I'll probably try that trick again over here. There. So I can see that that line and that line now, or that arc and that arc, are almost tangent with each other. So I know it's safe to add that tangency in because it's not going to pull the sketch too far out of shape now. And then there's one final relation that I want to put in before I start dimensioning this, and that is, again, because of the way that we've sketched this, the position of the part, if you like, I know that that plane there, the right-hand plane, that is still quite small, so it's quite annoying that the system hasn't scaled it up yet, but that plane there has got to be coincident with that point there. So that center point of the larger arc there needs to be centered between these 2 vertical legs, and the bit of our part that is in the center there is that right hand plane. So I'm ready to dimension it, so I can add a radius. I think the radius is a 10, and then the one at the top there is 5. Yeah, something like that. So it's just, again, none of this is sort of groundbreaking, but it's kind of practicing things that we've done already and using intelligent positioning of parts relative to the primary planes, so that if you do have symmetry within the final part at all, which obviously this is entirely symmetrical about one plane, it makes sense to try and center the part itself relative to that plane. It just makes defining the part a lot easier and arguably a lot more logical. If I then want to come back in here and modify anything at any point, changing these dimensions isn't going to lead to a part that is all lopsided relative to the planes. It's going to still stay centered where I intend it to, or down its line of symmetry. So when we get to that point, we're okay. We can exit the sketch. I think just for completeness, we'll now deselect the sketch. So in order to do that, I'm just clicking in some empty space, and you can tell it's deselected because it's not highlighted in blue anymore. Whereas when it's selected, it turns that sort of pale blue color. So we've got nothing selected. Now I'm going to initiate Sweat Boss Base again, so that we can see the behavior of this tool if you've got nothing selected. So I've got no profile selected, so I have to zoom in a little bit, click on the profile, sketch. There's the profile. It accepts it or not if it's not suitable. And then it auto selects the second box, which is the path. Then I can click on that one, see if I like the look of the preview. If it looks about right, click on OK. So yeah, that's the idea. So what I'm realizing is that that dimension that I talked about earlier, the 2.5, that may actually be 1.25. Yeah, I think that's the total distance between the inner flat sections. So from the screenshot, it's not immediately obvious, but you can see there's a 2.5, and I think that's referring to the gap between the two legs. So half of that, 1.25, do a little rebuild. So you can see I clicked on the end sketch there. It showed me the dimensions related to it. I then double clicked on the dimension and overtyped with the new number that I wanted. When you then hit enter, the model won't automatically change. What you have to do is what's known as a model rebuild. So there's a rebuild icon on the top toolbar there. Click on that, and then it will rebuild. If you want to get the full rebuild shortcut, it's Control and Q, which is kind of there's Control and B there, but there's two reasons I prefer Control and Q. Control and Q kind of runs through everything. If you're looking at a whole assembly, it will run through every single part and subpart, and it will rebuild every single one of them. But more than that, it's just that the Control key and the Q key are closer together on the keyboard. So hovering over Control and B is quite difficult, but Control and Q is quite easy. But anyway, you don't need to know that. You can just click on that icon at the top. That's perfectly acceptable. So we kind of finished that one, I think. Yeah, I can't spot anything that's kind of outstanding on that one. So I think we'll progress on. Let's tackle something a little bit different. Let's tackle the loft. Now, to give you kind of an intro about what the loft is, that image on the screen at the moment is quite kind of illustrative. As in, the main shape there, the thing that's highlighted in blue with the dimensions shown on it, is the loft feature. And then obviously, it might not be immediately obvious, but this is kind of it's a nozzle for kind of a heat stripping gun. So the guns that you get to strip paint off, it's kind of like a high-powered hairdryer. You get these stainless nozzle pieces that you can put on the end of it so that you can direct the hot air a little bit better. And this is kind of a simple design for something like that. But the loft shape allows you to transition from one profile shape, so I'm tracing a shape here, that the system in sketch mode calls that slot shape. So we've encountered that before, the slot sketch shape. And what it allows you to do is transition through 3D space to a different shape. So you can see there's a circular shape here as well at the back edge of this. So yeah, again, it has similar roots to the extrude, but whereas the sweep feature that we've just worked on is an extrude that you can essentially steer around corners, the loft shape, you can almost think of it as two extrudes that gradually morph from one shape to the other shape. So again, it has similarities with things that we've done before. but it has differences as well. And in terms of the setup of the loft, you need kind of three elements. You need two sketches, because obviously you've got to define what shape you want to begin as and what shape you want to end as. But then you need probably a base plane. So in this case, the front plane's been used, but then you need a new plane as well. So you can see here, there's a plane that's been created called plane 1, and it's been created in this case to be 80 millimeters away from the base plane that was used. So there's a plane and two sketches. Or if you don't use the base planes to sketch on, you obviously need two planes, a sketch on each one. So that's the setup of it. So let's see if we can kind of replicate what we're looking at there. And then in that part in particular, there's a few other kind of extra features just being added. One of them being the shell feature that kind of hollows out the part. And then there's a simple cut extrude as well, just at the back edge there, which kind of gets us into thinking about feature trees again. So you wouldn't just create a loft feature and that would be the design for your part. You create a loft feature that's sat within a series of features that allowed you to get to the final shape that you wanted for your actual design. So I'll minimize that one. I'm just keeping all these open at the bottom of the screen for no particular reason, but you can work like that if you've got enough memory on your machine and it's not slowing down particularly. You can leave them all open at the bottom here and just bring them back as you see fit. Oh, that was a little one just to illustrate something. So this was a simple job with some coving, wood coving. It kind of illustrates the sweep feature doesn't have to have smooth edges. So this was created as a shape that was sent along a path that had right angles on the path. So you can see the path shape there. So it has harsh angles on it. And the sweep feature is as happy to create a sweep with harsh angles on as it is to create a sweep with nice, smooth, flowing shapes on, like we've just done on that one there. Don't think that you have to do nice tangential corners like we've got on that one that flow around the corner. You can have harsh angles as well, and the sweep feature will do that just as easily. So yeah, don't kind of limit yourself in terms of what you think these features can and can't create in terms of the shapes. So let's create a new part. And we'll do the setup step first, which is create the two planes. So when I'm creating sweeps, this is how I tend to kind of manage them. Before I've created either one of the sketches, because technically I could sketch right now and put the first sketch on the front plane. But before I've even done that, I tend to put the other planes in. So creating planes, we may have done this once or possibly not at all, but creating new planes or any kind of geometry to allow you to kind of place sketches or reference is in that section there. So technically it's a feature, reference geometry. You can create planes, you can create axes, you can create coordinate systems, or you can create points. So plane. And then there's various methods of referencing where this new plane, where you would like it. But we're going to use possibly the most simple, which is just to select an existing base plane. So we'll click on the front plane. And then the readout there is saying, just with a single reference, the front plane, the position of your new plane's been fully defined. You don't have to bother with a second reference or a third. So this is by far the most simple method of placing a new plane. In this instance, just so that we're kind of oriented the same as the example, I'm going to change the offset to go in the other direction. So you can see there, the base plane's kind of coming out towards our viewers, the viewer there, and I want it to go in the other direction. So I'm going to click on that option there. flip offset, and then it kind of goes in the other direction. And then the depth away from the front plane that I want, I think I said it was 80 millimeters. So that's my second plane created. So I'll click on the green tick. Again, the system just names it with what it is and then a consecutive number. It just draws them. If I was doing what I advised you did with your parts in the first session, I'd then give it a name. So plane, whatever you want to call it. But in these tutorials, I don't think we'll keep naming everything. So let's create this first shape. So I'm sketching on the front plane here first. And again, the way that you initiate these loft features isn't really to tell the system you want to create a loft first. You go away and do the setup work first. So you create the plane, so you create the sketches. Then when you've got everything in place, then you initiate the feature, and you just kind of click on the, in this case, the sketches that you've already created. So slot shape, I'm going to center it around the origin. Again, it's obvious that this shape has a line of symmetry running down the center. So I'm going to make the sensible decision of creating all the sketches around one of my base planes. So the type of slot that I'm going to sketch in that case is the center point slot. So I want to center it on the origin there. Drag it out to the side, give it a thickness, and then start dimensioning. So top to bottom thickness there is 20. The length, we're not going to use our holding the shift key trick to do the limit to the limit there. We're going to do the center line length like that in this example. And that should be 55. When you put those two in, it should be fully defined. So we're going to exit the sketch. Then I'll rotate my view a little bit so I can better see what's happening. And then we're going to create a circular sketch on here. So I'm now on my plane that I created. I'm not on the primary plane. So center it around the origin. Tell the system it's 50 mil. Now it's been a while since I did this example, so this may require an extra step, but we'll persevere, and if we come up against issues, we may drop back into that sketch there. So yeah, again, I'm doing this without any sketch pre-selected, so you can see I don't still have the circle highlighted in blue because I've kind of clicked in some empty space. And that, normally you probably would leave it pre-selected, but I'm kind of forcing home the fact that if you do have things pre-selected and maybe you're not used to creating these features that regularly, you can end up with things entered into entry boxes that you're not aware of, or issues that you can't seem to get out of. So yeah, it's sort of cleaner to do it this way, where you've got nothing pre-selected. Then you tell the feature you want to create a lofted boss base. And then we just have to put a minimum of 2 profiles in this first box. That's all that's required to create a loft. So we'll pick this profile. You can see it's been entered into that box. And then we'll pick this one like that. And it has worked. So that's good. And then we tick OK, and we get that sort of shape. Now again, in the example that we're looking at, I believe that some extra options have been applied. And I suspect that because the intent of this design is to direct the air into that sort of slot shape as the air exits the heat gun. but it's also to provide sort of minimal turbulence as the air comes out, I believe. So I think rather than a shape that looks from the side view like that, like a sort of straight line almost, so you can see it's coming down from the outer diameter of the circle when you view it from the side, and it's taking the path not of least resistance but the shortest path down to the width of the nozzle. And I suspect that the effect that that would have is lots of vortices or lots of spinning air and disturbed air would come out at the end there, and it wouldn't be as advantageous as the shape that I'm about to create, and then I'll show you how to create as well. So something more like that, with sort of it starts out almost horizontal, and then it sort of tapers down, and then it kind of peters out towards this end. So a shape a little bit more like that, more like an S-curve, so sort of an elongated S-curve. And that's quite nice, or we're going to assume that that's the intention of this design. And the reason that we're going to assume that is because it gives us an opportunity to play around with these options within the loft. So initially, any lofted shape that you create, any lofted feature, it will transition between the various loft profiles as efficiently as it can. And in our case, you can see from a side view, perfect side view, that translates as just a straight line. So that's the most efficient or shortest distance between those two shapes. But often that's not what you want for various reasons. We've just talked about kind of one of those reasons, to do with airflow and smoothing it as much as possible. But what you can do is you can tell the system, you can say, the shapes that are defining this loft, I want them to have a certain amount of influence as the loft shape progresses. And the way that you do that is here, start and end constraints. So I think we clicked on the, which one did we click on first? The circle. So that would be the start of the loft, the circle, first sketch that you select. One of the options in here is normal to profile. Now we know that normal now means at 90 degrees to. So what that's saying is at 90 degrees to the first sketch. So the first sketch is sat on plane 1 there, so that when we put normal to profile, the influence of that sketch extends somewhat into the actual loft shape itself. So you can see its influence is kind of tapering away the deeper into the loft that we go, until eventually, down towards this end, we kind of resume that almost straight line again. But certainly initially, this shape kind of persists into the actual loft shape itself. And then we can do the same thing at the other end. We can allow this slot shape or this racetrack shape that we've sketched to exert an influence into the actual shape of the loft itself. So let's switch that one on, normal to profile again. And you can see the effect that that's having. Now, another nice little detail in here is you can vary the depth of that influence into the actual loft feature. So this option here, on both of them, the length of the influence there. So you can see I'm bumping that value up, and the racetrack shape or the slot shape is having more influence or less influence. I think we've got a bit too far there. But you can see the nice thing is you can create very kind of complex shapes with very simple inputs from you, the user. So this shape that we sketched and this shape that we sketched are very, very simple shapes, but by kind of tuning the end and the start constraints, you can end up with quite a complicated 3D shape that has it's not easily definable. It doesn't have a great deal of straight edges to it. It's got curvature in all 3 dimensions simultaneously. So yeah, you can come up with quite complicated shapes from quite simple inputs. Now, the one thing that we haven't covered in this example that we may return to, and we'll kind of cover it a bit later on, is that a loft doesn't just have to be a transition between two sketch shapes. This box will accept as many sketches as you want to create. So yeah, we'll revisit this and we'll create a loft that's got 3 sketches. But again, that's not even the limit. You can keep going on and adding planes into your part, as many planes as you want, and placing sketches on them. And the loft feature will accept all of those sketches in a single feature. And it will transition from one sketch to the next, to the next, to the next, to the next. Yeah, as many as you want. So again, don't think that just because we've used it in this particular setup that this is kind of the only method that you can use it. So I think we'll leave that as, or we'll leave the loft feature as both profiles are set as normal to profile, start and end constraints, and we'll just leave them as the default one in terms of their influence, because it gives that kind of nice S-bend transition between them. And then I think we'll finish this part in terms of adding the other features onto this. Again, it's kind of good practice. It gives us less of a view that you would only ever create one feature, which is very rare within a single part. You begin the part and then you add material and you chop material away and you kind of work with the part. So what we're going to do is create this simple collar section at the back here. So you can see from the feature tree here that's actually pictured in the screenshot, it's just a simple boss extrude. But given that it's going to kind of grow out the back of this shape, what we can do is we can recycle the sketch that was used to create this circular edge. So again, when we create features, any sketches that were used in the creation of that feature get kind of filed away inside the feature. So if we want to find one of them, we've got to browse inside the feature, find the one that we want, which is that one. Then we can say to the system, I've pre-selected a sketch, I want to create an extrude using it, and it does that. So rather than us having to create a new circular sketch, which is extra work, but it's a sketch that could possibly end up the wrong size. If someone came in and changed the loft shape, the circular sketch that we may have created after that may not be linked to it in terms of its diameter. So it's easier to do it this way. It's picked the wrong direction, so I'll flip the direction. I don't have a depth for that. Let's experiment and see what looks about right. I think about, yeah, let's have it as 18. Well, no, I think 15 is more. Yeah, that looks okay. And again, taking it back to the other week, the default is that that merge option is always switched on. As long as my extrude feature that I'm creating now touches or intersects with whatever's there already, the merge feature will be switched on. So I know that when I click on OK, the system merges all of this into a single solid block of material, or one solid body. So there's 2 other features here. The first one is, because these are made out of sheet metal, formed sheet metal, they have a thin wall to them. You can see that we've modeled ours up as a solid block that isn't hollow at the moment. So we need to hollow it out, which is the shell feature, which I'm sure we used a few weeks ago. In the shell feature, you tell the system how thick you want the walls to be. So I think we'll just have 1 mil. And then you click on any faces that you want to get rid of entirely. So in our case, it's that end face and that back face. And then if you want a preview before you OK the feature, you can. So you can see the kind of scale that 1 mil looks like in terms of the wall there. Click on OK, it hollows it out. We can now see through it. And then one final feature is just an extruded cut to put a little cut through in this collar so that you can slide it easily over the end of the actual gun itself. So extruded cut, I'm going to sketch on the top plane there. I'm going to use a center rectangle, and I'm just going to do something like that, I think, and then put some dimensions on it. So 15, and have a look, see what seems right. Yep, 10. 10 looks okay for that. So it's fully defined in terms of the sketch. It's a closed boundary, so I can OK the sketch. And then I just want this to fire off in two directions. We'll use the through all command, but we want to use the through all both directions, like that. So I want it to cut through both top and bottom of that colour. So yeah, that's pretty much done. And as I say, that's kind of set up from quite simple sort of beginnings. And you can see what I'm kind of illustrating here is you can make kind of wide-ranging changes with few dimensions and few real sketches. But you can come up with these quite organic looking shapes, certainly using the Loft tool, and to a degree using the Sweep tool as well. So how are we doing for time? We've got about 15 minutes left. I think we'll probably let's have a little go. We'll leave sweeps and lofts, so there's more content in that PDF, which hopefully with what we've just done in sweeps and lofts there, you could have a decent go at trying to create the two components there. So there's two components assembled together there. Again, it's similar components to this sort of split ring. These D rings are used to fasten together stainless steel rope quite often. And they have this pin that threads into one end, and then they have sort of a D shackle shape, a little bit like a bike lock. And obviously, this pin you could create quite easily, the actual cylinder section, just using an extrude, just a circular sketch that's been extruded. And then this end section here, I've left it visible, or I've left the sketches visible that created that. So that is a loft, and it starts out as a circle. It transitions to the same shape that we've just done. So that bit is the same as we've just done. But then the final sketch is on a plane. The final sketch is just a single point. So that's an interesting one to try in terms of setting that up as a loft, because you can end up at a single point in a loft. And then the main body of the actual D part, or the shackle there, is just a swept circle again. So you can see there's a circular sketch visible there. There's a path that it travels on. And then again, there's things like cut extrudes that we're familiar with, where you have to cut through to actually create a gap for the pin section to drop through. And there's kind of a guide there. So I don't think we'll do that in this session. I'll kind of leave that for you to have a little play around with. But what I do want to do is get into assembling assemblies, which we actually had a part that we were intending to do in drawings that we never got around to, because we never kind of have enough time in these sessions to do everything. So yeah, that was the activity that I was going to do if we had the time in the drawing session. So the task was going to be to try and recreate that drawing, and I'd shared these three parts there. So where it says SolidWorks drawings, up back above what we were just working on about sweeps and lofts. Chain case is a drawing of the overall assembly, like that. It's a simple assembly just with three parts on it. But what I wanted us to do is have a little practice in the assembly environment, just to kind of get our heads around just assembling things. And we're going to do this again next week, because there's a little bit of assembly that has to be done before we do some of the simulation. So we'll get practice more on this, but I just want to try this week. So if you download those 3 parts, I'm probably going to do the same. Unless I've got them, I might actually have them. So let's drop them into there. Yeah, I think I'll drop them in there. So if you download these as well, and then you need to load all 3 of them up in SolidWorks. Let's see if this works. So you can do bulk select here. When you go to open a new file in SolidWorks, if you just hold down Control, so you can see I've selected 3 files there. And then if I click on Open at the bottom of the screen, it'll open all 3 of them up. It may take it a little while to get them all open, but you'll see them appearing on the screen, and then it'll probably file the windows quite nicely, one behind the other like that. So what I'm going to do now, I think I'll shut some of my other stuff down, just because my screen is getting quite crowded now. I don't need to save any of these, so I'll shut that one down. I'm just tidying, so I've just got these 3 open. Yeah, so I've got these 3 open. They're quite simple parts, and all we're going to do is we're going to initiate a new assembly. So we've created parts up to this point. When we come to initiate a new file, there's parts, there's assemblies, or there's drawings. And we've looked at the workflow for doing parts, creating new parts, looked at the workflow for creating new drawings. Now we're going to create a new assembly. And by far the easiest way to create one, if you've got the part open that you want to insert into the assembly, is click on the window of that part. In our case, it's this, the belt chain case. Go to the file menu and go make assembly from part. Exactly the same way that we did with drawing, but this way we're telling the system we want to create an assembly instead. And then what you can do now is you can click somewhere in this window and it will drop a copy of that part. Do not do that in any instance. Always click on this green tick at the top left. What that will do is it will center your part around the origin of the actual assembly itself. So the other method that I just warned you against, where you just click somewhere in the window, what the system then does is wherever your pointer happens to be in the assembly environment, it drops a copy of the part right there. So that has normally no significance at all. It's just wherever your pointer happens to be at that point. And it fixes it in position there. So the big headache then can be later on down the line, if you want to position this assembly inside another assembly, the base planes in this assembly bear no relation to where the parts are positioned within it. So always click on that green tick on the top left to position your first part. And you can see, so what I've got here looks a lot like the part modeling environment in that it has a front plane, it has a top plane, it has a right plane, it has an origin, and now it has a single part sat within it. And if I browse inside that part, that itself has a front plane, a top plane, a right plane, and an origin. And if I keep the origin of that selected, so you can see I've clicked on the origin of the part, I can see where that is, it's a little blue dot there. And then I click on the origin of the assembly, they're in the same position. So by clicking on that green tick in the left there, that is what I achieve. I put the part origin coincident with the assembly origin, which is kind of 99% of the time, that's the way that you're going to want to kick off your assemblies. Sometimes not, but more often than not. So yeah, we have an initial part in there now. So now we're going to bring the other two parts in. So insert component is what I'm going to click on at the top of the screen there. You can see I'm in a specific assembly tab at the top, which gives me all these assembly options in the menu at the top, or the ribbon at the top of the screen. So insert component. It will tell me what components I already have open in SolidWorks. In our case, I think we'll tackle the lid first. So if you click on the lid, then what happens is the lid gets attached to my mouse pointer and it just kind of moves around. I don't want to drop it in any particular place at the moment, so I'm just going to say drop it there. That's fine. Then I might rotate around to sort of get a better appreciation of where it is relative to my base part. So currently, this first part that I dropped in, I cannot click and drag that. It's been fixed in position with its origin coincident with the origin of the assembly. This part, however, I can just click and drag it in all directions. So this one's totally, if you want to use the same terminology as when we're sketching, it's totally underdefined, its position, whereas this one is fully defined. Its position is fully defined. So what we're going to do is we're going to rotate round, so we're looking at the underside of it there, and I'm going to click on that lower face and then rotate back round, zoom in a bit, hold down Control and click on that top face. And then what we get are some options here for what are known as assembly mates, which are very similar to some of the options that we use when we're in sketch mode. So these are kind of equivalent to relations in sketches. And it's that one, the coincident, the first one there that I want to click on. And when I do that, those two faces become coincident with each other. So you can see they're stuck together, although this part is still free to move in X and Z directions. But in Y, it's been locked now. So it cannot move in Y. So I'm just quickly going to lock it in Z and X now. And the way I'm going to do that, because of the specific geometry of these parts, I'm going to get the internal bore of that hole there. So I'm going to click on that. Then I'm going to hold down Control and click on the internal bore of that matching hole there. And then again, the system will auto offer me mates that it thinks are relevant to those two surfaces that I've clicked on. And the one that I want is concentric for those two. So they're both cylinders, essentially, and concentric will lock their center points to be concentric with each other, or coincident with each other. Now, again, I can investigate how this is still free to move. You can see the freedom of movement that it has. So I'm gradually locking it down, gradually locking it in place. Now, this next one's a good test as to whoever modeled this part up, did they get the positions of these three holes exactly identical to the matching holes on the actual case itself? Because if they didn't, this next step is not going to work. But let's see. So I'm going to get the internal kind of cylindrical face of that hole, hold down Control, select the internal cylindrical face of that, and make them concentric with each other. Yes, they match perfectly. Had the distance on this lid between that hole and that hole been slightly different to the lower, it would have thrown an error, but it didn't. So I think if we can really quickly now just bring this bottom section in, because we've got about a minute left. So I'm going to go insert components again. I'm then going to go, I think it's boss. Yes, I was correct. It is the boss that we want to bring in next. So you can see I'm kind of, before I drop this one in space, I'm trying to kind of get it near to there. So I'll probably click somewhere about there. Yeah, I managed to get it reasonably near. Yours might end up being off here over in some empty space somewhere. So what I'm going to do, I'm going to do something similar. I'm going to get that cylindrical face there selected, hold down Control, that cylindrical face, make them concentric. Now, the system picked the wrong sense of concentric there. It's flipped it the wrong way. But you can change that. You can see there's some flip mate direction arrows there that I'm clicking on now. So that's the direction that I want it. Then it's disappeared inside, but I can click and drag it because it still has quite a lot of freedom at the moment. And then again, those little pegs allow me to position it in this particular design. So I can get the outer surface of one of the pegs, hold down Control, get the inner surface of one of those holes, make them concentric with each other. Check out how it's free to move. Yeah, it's only free to move on axis now. It's not free to spin. So what I want to do then is get that flat face there, hold down Control, that flat face on the underside, and make those two coincident with each other. And then that should be fully locked in place. And again, the system uses a lot of the same terminology here as it does in the sketches. So you can see I have that fully defined readout at the bottom of the screen. It uses the same terminology. Fully defined in an assembly means that none of the components have got any degree of freedom. They're all fully defined or fully locked in position. And I can check that out by trying to drag things around now. And I shouldn't be able to at all. So that's kind of a little intro to assembly setup. And it's probably worth saving that, I would say. And then we may kind of come back and revisit that at some point. So yeah, I think we're going to have to sign off because I've got to rush off to another session now. But we'll come back in, and what I'll do during the week is I'll investigate how to get SolidWorks upgraded as well, and I'll re-release another email, possibly with some extra guidance on that, because I want to kind of get into using the simulation side next week. So yeah, keep an eye on your emails is what I'm saying during the week, because I'll send something out and you'll need to action it before this time next week. Okay, I think I'll sign off and I'll see everyone next week.